All right, I'll say it again, okay? Here. Always put what the researcher expect in alternative hypothesis. And when we do the hypothesis testing, we have to make some conclusion. Okay, there's formal setting for conclusions. Okay, we always reject the null hypothesis. We start with reject the null hypothesis. And what do we mean? We support or accept alternative hypothesis, right? Or we cannot reject the null hypothesis. And what's the conclusion here? When we do not reject the null hypothesis, either reject the null hypothesis or do not reject the null hypothesis. This all in terms of null hypothesis. Either reject or do not reject. And reject the null hypothesis means support or accept alternative hypothesis. And cannot reject, do not reject. Null hypothesis means what? We cannot support. We cannot support the alternative hypothesis. Okay, I'll show you how to make the conclusions, in the further steps. Okay? All right? And so the typical testing technique in econometrics is to hypothesize an expected signs and or values. Okay, here we always say zero. Zero means just the signs without specific values. Okay, so hypothesize an expected sign or value for each regression coefficient except the constant term. We don't do the hypothesis testing on the constant terms, okay? And then to determine whether we reject or not reject the null hypothesis. You see what I'm saying here? Okay? Is to hypothesize an expected sign for each regression coefficient and then to determine whether reject or not reject the null hypothesis. Okay? And this is about the concept of the first step, null and alternative hypothesis, or state the null and alternative hypothesis, our step one. Okay? Then I'll go on to say some topic about this hypothesis testing. Okay, there are two kinds of errors when we make a hypothesis testing. Since we do the research, we collect the data, and we made some conclusions. We're not perfect people, right? So there are two kinds of mistakes we will make it. The first one is type 1. We call it type 1 error. Type 1 and type 2 error. The first one is called type 1 error. What do we mean by type 1 error? We reject a true null hypothesis. Reject the true null hypothesis. So for example, if beta 1 is less than equal to 0, if this is true, we don't know. If we know, we don't have to do the hypothesis testing, right? We don't know. Therefore, we do the hypothesis testing. Okay? So if the null hypothesis is correct, it's true, means if it is correct, then we reject it. This is called type 1 error. And what is the type 2 error? We do not reject a false null hypothesis. If it is false, and I do not reject it, this is another mistake. And this is called type 2 error. Okay, then let me go on to the examples, then I'll come back here. Okay? I'm going to put it bigger. Okay. Then okay, now I wanted to make the examples. Okay, if now I'm working with the hypothesis testing, okay, the alternative hypothesis, okay, this means the defendant is not innocent. Usually in the jury, if you have some kind of criminal, okay, the dividends may be the one, commit the criminal, okay? So we have these criminals, or the jury have criminals in front of him, okay? So what is the purpose for this jury? What does he want to prove? What does he want to collect the data to investigate? He wanted to investigate whether he is guilty or not. He or she is guilty, right? This is very important. The jury wants to investigate whether the defendant is guilty or not. Does the jury want to collect the data to prove the defendant is innocent? No. He wanted to, since it is the suspected criminal, right? That's what we call it, defendant, right? So what he collect the data is to show whether he made this criminal or not, right? Whether he commit the criminal or not, right? So this is the purpose. So we wanted to show, so the research hypothesis here is the evidence, the defendant is, since I'm using the terms like here, okay, not equal to. So I'm using is not innocent. Usually it is guilty, right? And the alternative, the null hypothesis is innocent. And I also can put this way, usually in a democratic country, okay, unless you have evidence to show somebody commit a criminal, will never say that he is guilty. Okay? So the status quo is always show that, it's always say that the defendant is innocent until you collect the data, you collect the evidence to conclude that the defendant is not innocent. Okay? And understand what I'm saying here? So now, let me ask you, what is the type 1 error? What is the type 1 error here? Let's go back to the definition of the type 1 error. Reject a true null hypothesis. So remember, what is my null hypothesis here? I need to put this back and forward. So let me write it down here. Okay, I'm just using A. Is innocent. C-E-N-T. Okay, then my alternative hypothesis is A is not innocent. What is the type 1 error? according to the definition, we reject the true null hypothesis. What do we mean by that? So what's the type 1 error? What do we mean by reject true null hypothesis? So if A is innocent, if this is true, okay, and we reject he is true, we reject A is true. So what does that mean? Since our alternative hypothesis, A is not innocent, if we reject the null hypothesis, then we accept or support alternative, right? So the type 1 error means that if actually, in fact, A is innocent, but the conclusion say that A is not innocent, this means type 1 error, right? Can you understand what I'm trying to say here? Then try it again. What is type 2 error? Do not reject a false null hypothesis. Do not reject a false null hypothesis. Means this is false, right? So A is not innocent, but we do not reject A is innocent. Actually, A is not innocent, but we do not reject A is innocent. We don't accept A is innocent. We just do not reject A is innocent. I'm trying to confuse all of you. Do not reject A is innocent. Doesn't mean A is innocent. Doesn't actually accept A is innocent. That's what I'm saying, that do not say accept the null hypothesis. Say do not reject. So if we say, actually, null hypothesis is false. So actually A is not innocent. And I do not reject A is innocent. But I didn't accept A is innocent. I just do not reject he is innocent. Because my purpose, the jury's purpose, is not to prove A is innocent. He wanted proof whether A is not innocent. And maybe there's no sufficient evidence to show A is not innocent. Therefore, I do not reject A is innocent. Do you see the difference? So just, to remind yourself that alternative hypothesis is the research hypothesis, is the purpose you want to show the evidence. Okay? So this is one. Let me show it here. So type 1 error turned out to be sending an innocent defendant to jail. Type 1 error means reject the true null hypothesis. He is innocent, but you reject A is innocent. Therefore, sending an innocent defendant to jail, right? Okay? The type 2 error is do not reject the false null hypothesis. So he is not guilty, he is not innocent. But you do not reject A is innocent. Means freeing a guilty defendant. Now, I wanted to ask, since we may make mistakes, the jury may make mistakes of type 1 error or type 2 error, okay? Which type of error do you think is more serious? Type 1. Yeah. You put sending an innocent defendant to jail, right? And this one is just freeing a guilty defendant. He may commit a crime again. Then in the future, then he or she still have possibility to get caught. But this one, you already put into the jail. Maybe it's, it's a death punishment. Okay? So type 1 error is more serious than type 2 error, usually. Okay? Then, okay, most jury members want both levels of error to be quite small. Even type 1 error is more serious than type 2 error. But those two errors, the jury likes to put these errors as small as possible. Okay? But such certainty is impossible. In the real world, decreasing the probability of type 1 error means increasing the probability of type 2 error. What does that mean? So let's go back to this. If sending an innocent defendant to jail, this is type 1 error. If this one decreasing the possibility of type 1 error means that since we know that type 1 error is serious, so we wanted to reduce type 1 error as, I'm sorry. Okay. And you want to reduce the type 1 error. So that means what? Well, we are afraid of sending an innocent defendant to jail. Therefore, we need to collect more confidence evidence. Okay? In that case, the possibility of freeing a guilty defendant is increased, right? If you didn't make this kind of mistake, you may make these mistakes. Because these two are related, right? You're afraid of sending an innocent defendant to jail, then you should have enough evidence or very strong evidence to show that he is innocent. Therefore, freeing a guilty defendant is easier. Therefore, the probability is getting higher. Okay, so usually, since type 1 error and the relationship of the type 1 error is inverse relationship. Means if you want to decrease the probability of type 1 error, then means that you are increasing the probability of type 2 error. Let me put another example. Maybe it's more, you can have more sense about it. For a teacher, is always testing hypothesis of individual students in the class. What do I do? What is my research hypothesis? What do I want to prove? What is my What do I have to do, for every semester to all of my students, to all of my students? What should I do? I should send a grade, right? So what is my hypothesis testing here? What is the alternative hypothesis? What do I want to prove? So what do I? A is what? A is for some certain students. A what? What do I have to wanted to do for my alternative hypothesis? What do I want to prove my students? I have to collect the data, right? So I give you all the assignments. I'm collecting the data. I'm collecting all the evidence. Okay? Then I want to do the hypothesis testing. And what is my alternative? What do I collect the data for? Yes.
Decide to pass the class or not.
Yeah. So what is my alternative hypothesis?
The grade is over 60.
Let's say just pass or fail.
Oh, okay.
I don't set any criteria.
Okay.
Just like here, innocent or not innocent. So what do I have to put here? Alternative first.
Pass.
We put the pass here?
Yeah, yes.
Any other opinions? Do I want to prove whether you pass it or not?
Yes.
If you are a teacher,
Oh, learn the content.
just say pass or fail.
Oh yeah, then there is pass. It's pass.
In alternative?
In
Do I have to collect it? Why do I have to check attendance for?
Because we
Yes.
don't wake up in the morning. Because we don't wake up in the morning. So
What?
I said we don't wake up in the morning. That's why you have to check.
I don't wake up in the morning. Oh, you don't wake up.
And actually I had doubts about it today. Am I going to wake up today or not?
Yeah. This is your
About it.
okay. This is your decision, and to whether to attend the class or not, right? And actually, checking attendance is, really, it's not my purpose. Okay, my purpose is to know you and also see any special or, serious, bad things happen to you. Since all of you are international students, right? So I need to know whether you are okay in our country. And I like to know all of you. I like to match with your face and the names. So check attendance is not really my purpose. Okay? So actually, just like this one, the offense is innocent. As a teacher, okay, I cannot suspect any of the students coming into my class without learning. I cannot expect that. I cannot suspect that situation. I should tell myself that every student is love to learn this course. Right? So, this is the, this is really, right attitude of the professor or teacher, right? I should suppose all of you loves to learning and you wanted to pass the course. So what do I want to prove for? Fail. So fail is my purpose for the alternative hypothesis. And I need to assume all of them, passes. Just like here. I should, unless I have sufficient evidence to show the students doesn't learn, then I'll fail it. Otherwise, pass it. Right? What means arrows I have? What kind of arrow? 2 arrows. Type 1 arrow. What is the type 1 arrow here? Type 1 arrow means fail the students. In fact, he should pass. Right? This is my type 1 arrow. What is the type 2 arrow? Pass it. In fact, he should fail. Right? Which arrow is more serious? Type 1 arrow, right? It should pass, but, fails. And I wanted to say that in this example, how do you show decrease in the probability of type 1 error will increase in the probability of type 2 error? What do we mean by decrease in the probability of type 1 error? Type 1 error means A fails. Actually, A pass. Okay, if I want to decrease this probability, means what? I can make the assignment easier. Or I do something, means what? Means my criteria, I set the criteria lower. Okay? So if I set the criteria too low, then I made a type 2 error. So setting the criteria, my minimum criteria to pass means 2 errors. One is type 1 error. The other one is type 2 error. And these 2 errors is inverse relationship. Means my I have to set this criteria here. Okay? But if I'm afraid of making type 1 error, so I make it lower. Then if I make it lower, maybe their students pass, but they should fail. Understand what I'm saying here? So this is the example relationship, the inverse relationship of probability here of type 1 error and type 2 error. Okay? So since in most of the situation, type 1 error is more serious. Therefore, when you do the research, you have to set the type 1 allowable type 1 error first. Okay? So let me show one tables. Okay, this one. Okay, this is a conclusion. When we do the conclusion, do the hypothesis testing, there are 2 conclusions. One is reject null hypothesis. The other one is do not reject. Oh, by the way, in our textbook, they are using accept null hypothesis. I don't know why the author say in this way. Usually, we don't do that way. So please remember, do not say accept null hypothesis. Just say, do Do not say accept null hypothesis, say do not reject. Okay? So we have two conclusions. One is reject null hypothesis, the other one is do not reject the hypothesis. And actually, null hypothesis is true. There's two situations. One is null hypothesis true, the other one is null hypothesis false. When we do the hypothesis testing, we really don't know null hypothesis is true or false. Otherwise, we don't have to do hypothesis testing. If I already know, then since if I already know this is the truth, then the other one should be false. Right? So I don't know whether null hypothesis is true or not. Therefore, it's come out with two situations. And the first one, we just say that reject the null hypothesis when null hypothesis is true. So this is probability of type 1 error. Usually we're using alpha. Okay, and this is universal notations in hypothesis testing. We're using alpha, and this alpha also called significance level. Remember those words. You should recognize all these terms. When we say the probability of type 1 error, it means significance level. And usually we denote it as alpha. So this is the type 1 error. And type 2 error is when null hypothesis is false, but you do not reject the null hypothesis. Okay? So the probability of making type 2 error, usually we note it as beta. And this beta is different from what we showed it, this coefficient here. Okay, although they are using the same notation, but it's really different meaning. Okay? And this 2 is our correct decision. What does that mean? When null hypothesis is true, you do not reject the null hypothesis, right? If A pass is true, and the professor do not reject this one. Do not reject null hypothesis. If actually A pass and do not reject it, means we conclude A pass. Okay? And this is what we have another terms called confidence level. And it is using 1 minus alpha. So this is a probability, right? Alpha is a probability. And the whole situation, this one is the whole situation under hypothesis, null hypothesis is true. So this is a probability, and this one is the 1 minus alpha. Okay? And this is also a correct decision. We call it power. It means null hypothesis false and reject the null hypothesis. Null hypothesis false means A fails and the professor fails him or her. Okay? So, confidence level. So, based on the definition here, we say that if this professor is confident, means when the students pass and the professor pass him or her. So the confidence professor is, the students have confidence that the professor will pass him. In fact, he passes. And this is also called power. This means what? The students should fail, and the professor fails him or her. So this is a powerful teacher. Is the one who failed the students. In fact, he or she should fail. Okay, so this is a basic concept. Yes.
Professor,
In this case, the lower the significance level, the better.
Lower significance if you lower this one, means this one will be higher, right? Okay? So it's better. But you lower this one is increase. And this one increase, this one decrease. That means if you lower this one, okay, those who should pass, the professor pass it. Okay? And since this is lower, this means increase. The increase means what? The power decrease. And this, what does this mean? If the students has to fail, the probability to fail is smaller. Okay? All right? So I think it's, since type 1 error is more serious, therefore, when we do the research, let me see this way. Okay, usually make type 1 error is more serious than type 2 error. So the allowable type 1 error for business research is already set it less than 10%. For all the business research nowadays is already set it less than 10%. Okay, so when you do the research, the step 2, okay, like the, let's see the step 2. Step 2, choose a level of significance and therefore a critical t-value. Okay, let me explain this one. So set up a significance level is what? Is alpha, right? So we set up significance level, making type 1 error. This is significance level, right? Okay, so alpha is already set it as less than 10%. So you can use in 10% or 5% or 1%. So usually when you see the examples, always show the 5%, but it really doesn't mean you have to use the 5%. Whatever in the business research, lower than 10% is allowable. Okay? All right? So second step is set significance level. Okay? Then the critical t-value. Okay? Let me explain this one. Okay? I wanted to show all of you a table at the back of our textbook. Okay? And would you please turn to the page, Appendix B. Appendix B and table B-1. You all see the tables? I don't have the tables here, but you have to see, show, yeah. B1. We all have that. Table. Okay, I'll make sure everybody have the table. Appendix B. Make sure you're all in that page, because I need to have all of you to how to use those tables. Have that one? Table. You all have that?
The table.
Yeah. Textbook. Do you use e-books?
No, I didn't.
You don't have textbook?
I have it with me.
Appendix B at the back of the book. At the back of the book. So you're with me. Okay, this is the T table. Okay, what do we wanted to use this T table? Okay, again, this is also the probability distribution. T probability distribution. Okay, I will introduce you that since we want to do the hypothesis of test of this one. So I need to collect the data, right? Okay, after I collect the data, then I do the estimation. Therefore, I will end up with the beta. So for example, this one. Beta 1 hat. Okay? The probability distribution of beta 1 hat, okay, T. If I use the expected value of beta 1, and okay, this one is what we call T statistic. This is what we call test statistic. Statistic. When we want to do the regression analysis and we collect the sample, after we have sample, then this is the real estimate of the beta 1. So we call it beta 1 hat. And this one here will be the null hypothesis of the beta 1. Okay? Since we're testing 0, therefore here is 0. So whether we do have subtract from 0 or not, it really doesn't make any difference, right? Okay, so this one, we may have like this one. So the numerator is just beta 1 hat. And this one is called standard error of the beta 1 hat. Okay, according to the distribution, the sampling distribution of beta 1 from chapter 4, we do have the mean as well as the standard deviation. The standard deviation is the shape of the T distribution, whether it's a fatter or skinnier. Okay? So remember, when we do the output from eViews, the first column is coefficient. Then the second column is what we call standard error. Okay, and this is a number from this formula. After we have this number, and we do have this standard error, if you use this one divided by this one, come out with the T value. And this is what we call test statistic. And this test statistic has T distribution with degrees of freedom. And this degrees of freedom is equal to the sample size minus K. And this K is including intercept. Okay? That's why we wanted to check with this T table. Sorry. So we will get back to this one later on using the real examples, okay? All right? let's see how do we read this T-table, okay? The first column is called degrees of freedom. From this table is from 1 to 30. Okay, 1 to 30 is by step of 1. Okay, then after 30, they just make it 40, 60, and 120. Then more than 120, make it infinitive. Means the sample size, the degrees of freedom is large. It's large enough. Did you see the normal? Normal means standard normal distribution. Okay, standard normal distribution and the T distribution. Okay, I'll draw the diagram about T and normal. Okay, standard normal distribution. Okay, it's like this way. Okay, this is symmetric, and the mean is 0. This is standard normal distribution. Okay, and the relationship between the Z and standard normal was the T distribution. T also is symmetric, but is the tail is a little bit fatter than the standard normal distribution. So usually we can draw the diagram something like this one. You know, so the degrees of freedom, the T, this is T. Oh, I should use the different color, maybe it's easier. This one is Z distribution. Usually we call this Z distribution. This is T distribution. The shape of T distribution depends on the degrees of freedom. I mean, the fatter or skinnier. But Z distribution, the standard deviation, always 1. Okay? So you can see that they're pretty similar. So in this table, tell us that as your degrees of freedom is large enough, then you can just use standard normal distribution. Okay? And this is the first column for degrees of freedom. Then, did you see the level of significance from the second column to the last column? You see that from the table? Level of significance. Did you see one-sided and two-sided? Okay, so this is what I need to draw the diagram here and let you all understand how to read this T-tables. Okay. Since we say two-sided and one-sided, this is really related to here, one-sided, two-sided. So two-sided means either we have to consider either positive relationship or negative relationship, right? Okay, so look at the, let's see if I have the degrees of freedom, which is 20, okay? Then if you have one-sided, 1%, okay? 10%, I'm sorry, this is T, okay? 20 degrees of freedom. Well, let's take a break. Then I'll explain this T-table later on, okay?